Okay guys, welcome to an Introduction to Python Programming workshop. So here will be the workshop outline for today. I'm Ku Kaiwan, a JC1 student from NUS High who is interested in computer science. And this is
Hi.
Zion and Pranaya, who are also the other speakers. This will be the course outline for today. So we'll have 3 acts. Act 1 will be Introduction, Operations, and Variables. And Act 2 will be Types, Conditionals, and Functions. And the last act will be Loops, Lists, and Modules. The structure of each act will be like this. There'll be 2 to 3 chapters, and after that, there'll be a 15-minute Q&A session in breakout rooms after most chapters. And then there'll be 1 to 2 examples per chapter, 2 to 6 minutes each. So this is the suggested software for today. You should have already downloaded the IDLE, the prerequisite software in your email. But if you're unable to download IDLE, or you cannot use it for some reason, you can also use an online Python environment, which is called Programmis. So if you just click this and go open link, you can go to Programmis, which is a Python online compiler. And how you use this is you can just like type whatever code you want to print in here, or like whatever code you want to run in here, and you press run, and then the output will be here. Okay?
Also note that you can also just type into the shell, which is very useful for some of the things we're doing today.
Yeah. So moving on to the first chapter. Chapter 1, an introduction to Python and IDLE. So you must be wondering, why learn programming? Well, firstly, the future career. If you didn't know, the average salary for a developer in Singapore is around 6,000 per month, which is like really high. And there are many booming areas that involve technology like fintech and AI. Secondly, you can also learn computational thinking, which will make you learn analytical thinking skills, which are useful in mathematics, science, and even arts. Lastly, you can learn programming just for fun. Here's a disclaimer about the truth about programming. You must note that memorization is not the key, unlike other subjects, and that programming is about thinking and approach, and not about memorizing lines of code. And lastly, you'll also spend a lot of time debugging. So you can see like here's a diagram of the average programmer's life. Wow. Why are you guys learning Python? Well, it's a beginner-friendly language, which is easy to understand and comprehend. And it's also surprisingly powerful and versatile. Here are some examples of libraries that you can use in Python. So TensorFlow and PyTorch are AI or machine learning libraries you can use in Python. And OpenCV, you can use it for computer vision. So you can in fact do a lot of things with Python. So we all know that Python is a language, and every language will have its rules. So for English, it's a subject-verb-object rule. And as for Python, Python is extremely strict with syntax. So you need to get whatever you type in correct, else it'll give you like an error or output that you might not want. An example is case sensitivity. So lowercase pain is different from uppercase pain in Python. Yes. Okay, here's an exercise 1, hello world. So what I want you guys to do right now is open up IDLE in your computer, or Programmis if you don't have IDLE, and just type print hello world. Okay, and then you can press enter. And I'll give you guys like 2 minutes for this. Okay, so I hope that most of you have done it by now. And this is the output that you should be getting. So when you type print bracket inverted commas hello world in your shell, you should be seeing this hello world output. And why does this work? So here's a brief introduction to functions. So as we tried in the last example, print is indeed an example of a function. For functions, there are a few things that you must take note. Firstly, there's the parameters or arguments, which is the input. So here you can see that hello world is your input to the print function. And then your input will go into the function, and the function will carry out an action and also return an output. So the action here is that it will print your inputs into the shell, and it will also return your input. That's what the print function does. So the idle shell is normally used for small scale testing. So this is the shell. You can see that there's like some funny text at the top, and then these like 3 arrows, this is the idle shell. It's used for small-scale testing, and you can just press enter to run lines of code. But note that your code won't be saved, so you shouldn't really try to code on the idle shell. You should code on the idle document, which is used for your actual code writing. So to make a new document, you can press Ctrl-N, and you can press Ctrl-S to save your file as a Python file. And remember to do this frequently, or else you might find that you accidentally delete all of your progress, which is not something that you want. To run your program, just press F5 or function F5 to run the program. And you must save the program before running. When you run your program in the idle document, it brings you back to the shell, and it resets everything in your shell so far. And here is commenting. You can use the hashtag symbol to add comments into the code. So this is a comment. It will not run. And you can see that you have the hashtag in front of it. Comments do not run. And comments are good coding practice because it serves to communicate the purpose and context behind the code. And it's something you should comment a lot, especially if it's a large project or you're working with multiple people, so that they can know the function of what you're writing. So here's an input and output demo. So you can just try to type this line of code into your idle, print bracket, input bracket, type any word here and press enter, and you press enter. And what do you think the argument, action, and return of the function input will be? So I'll just give you 1 minute to type this into your idle. Okay, I hope that you guys have typed this line of code into your idle. So this is what you should be seeing. Type any word here and press enter, should be printed, and then it'll take the user input and then it'll print it back out. And now we'll move on to chapter 2, which is operations. So in Python, you can do a bunch of operations on your numbers and other things. Here are some simple operators you can do in Python. Well, obviously there's the addition, which is a plus symbol. So you can type into your idle shell 5 plus 3 and it'll return you 8. And it's similar with your subtraction, which is your minus sign. Your multiplication is an asterisk. Your division is a slash. And as for your exponentiation or power, it's double asterisk. So exponentiation is if you want to find 5 to the power of 3, then you do 5 double asterisk 3, and they'll give you 1 to 5. So here's a simple exercise, and I'll give you guys 2 to 3 minutes to do. So use your idle shell to compute the following. So just type the code into the idle shell, and we'll reconvene after 2 minutes. Okay, so 2 minutes is up. And as a reminder, if you can't use your idle shell, you can use Programmers. You can just search Programmers and you can use the online Python compiler. But yeah, this is the results that you should be getting. So for the first statement is just a simple division. So you just get the output. For this, you firstly add these two together, then you subtract this because you read from left to right, and you get this result. And as for this, what it's doing is that, remember the double asterisk means that it's exponentiation. So you're going to be calculating 894 to the power of 70, which is why you probably are seeing a lot of lines of numbers on your idle shell. And as for number 4, it gets a bit more tricky. So since this is a multiplication, we calculate the multiplication first, so 21. And it should be 5.5 plus 21 equals 25.5. Error. And as for this, you calculate the brackets first. So 12 times 3 equals to 36. So here is the order of operations, which I'm sure that you guys have probably seen before, probably in math or something. So remember, it's BODMAS. Brackets are first, priority, so you always calculate what's inside the brackets first. Next is the order, which is your exponentiation or power, so your double asterisk. Next is your division and multiplication, which have the same priority, and addition and subtraction are last, and they also have the same priority. So if they are multiple of the same priority, you can just read it from left to right. We also have some other interesting operators like floor, which is integer division, and modulus. For floor division, it's like you divide it, and then you round down your result to the nearest integer. So you don't round up, you always round down. So if it's like 4.7, floor division will make it become 4. So as you can see, 27 double divide by 6 equals to 4. As for modulo, modulo is the remainder in the division operation. So say you divide 27 divided by 6, you'll get 4 with a remainder of 3. And what this modulo function does is that it will return you 3, which is the remainder. So here are some things that you can try.
看才都没有 start。
A reminder to turn off your mics if you are unmuted. Yep, so you can try to type in these few lines into your code. And reminder that if you want to put a negative number, you must put a bracket around the negative because remember, like subtraction is of the last priority in BODMAS. So you can try these lines of code and see what you get. Okay, so I hope you guys try to type this in your idle shell. And here's another exercise for you, which is the revised order of operations. So now, devise your own examples to find out where integer division and modulo are ranked in BODMAS. Because they aren't in BODMAS, so like which priority would they be in BODMAS? So try to just type a bunch of calculations in your shell to find out where their priority is. And I'll give you like 2 or 3 minutes. Okay, so I hope that you guys have tried to find out to do this exercise. And here are like some examples of what you can do. So firstly, you can try this statement. 5 plus 7, floor divide by 3. Then if the output returns 4, it means that 5 plus 7 will calculate first. Whereas if it returns 7, it means that floor division is of higher priority. And what the output is actually 7. So it means that floor division is of higher priority than addition or subtraction. And next, we'll try to see if it's higher than multiplication and division. So we try this statement here. 7 divided by 3, floor divided by 3. And we can see that the output is 0. So we can conclude that floor division is lower than or equal to multiplication or division. And lastly, we try this statement. So we put floor division at the front and division at the back. And we actually see that floor division is higher priority in this case because it returns this funny decimal. And as a result, we can conclude that floor division is of equal rank to multiplication and division. And remember that if they're of equal rank, the one with high priority is the one which is more left, or the one which comes first. Yep, so this is the revised order of operations. So you have your board mass, and then you have modulo and floor division with the same priority as division and multiplication. And now, onto the chapter 3, which is variables and assignment. So what is a variable? This is like a visualization of a variable. A variable is a box which contains something inside and it has a name, value, and type. So as you can see here, the name of the variable is x. And the value of the variable is 3 because the value is inside the box. And the type in this case is an integer, but we'll cover that later. Variables can store many types, such as integers, floats, boolean, strings, lists, functions, and many more. And here's an example of how you can assign a variable in Python. You can simply type x equals to 3, and you have created a variable. But before you create a variable, you must first know the variable naming rules. Most of the time, your variable should be a unique name, so try not to reuse your variable names. And your variable should be multiple letters long, can be multiple letters long. And your variable cannot start with a number or more symbols. For example, you cannot start your variable with 5, which is a number, or @ which is a symbol. Your variable should also not be a special name used in Python. For example, you cannot assign a variable to like a special function like print. You can't make print a variable, or like you shouldn't try to. And you also cannot use input as a variable name. One thing to note that variable naming is also case sensitive. So for example, lowercase pain, lowercase p, is different from capitalized pain. So you can make both variables and both will be like separate variables. But what should you name your variables? Well, by convention, here are some variable naming conventions in Python. Firstly, you should start with a lowercase letter. For example, lowercase result versus result. Your variable should also carry meaning. So your variable shouldn't just be like x equals something or like y equals something, unless your it means like x-axis or something. So it should be, your variable naming should be like remainder instead of like variable 3, because that's not very meaningful. Underscores replace spaces. For example, if you want to name a variable input file, you can name it input underscore file. And here's how you assign a variable in Python. So in this code, equals is the assignment operator, and result is your variable name, and 3 is a value that you want to assign to result. So you can try to type in result equals 3 in your Python shell, and if you type in like result, then it'll show you your variable output, your variable value, which is 3. And you can also reassign variables. So you can reassign result from 3 to hello world, and then it'll be hello world. Yeah? As an aside, when you type something in shell, typing a variable will display the value that it holds. So if you just type the variable in the shell, it will output your value. But if you do it in document, then you have to type in like print num to actually like show the value of the variable. Variables are extremely powerful, and you can assign variables in terms of other variables, including themselves. So as you can see here, we have 3 variables. Result is 6, result 2 is 15. And result 3, we can assign it to result plus result 2. And it actually does the addition operation. 6 plus 15 will give you 21. You can also assign a variables in terms of itself. So you assign result equals 6, and then you assign result equals result plus 7. And what it does is that it takes result, which is 6, it calculates 6 plus 7 equals 13, and then it will assign 13 back into result. And that's what you see here. And this is quite similar with floor division. So when you assign a variable in terms of itself, it does the assignment last. So as you can see here, what it does is that it calculates the operations on the right, and then it gets the value. Then it does the assignment to assign the value into the variable. Here is like some shorthand operators. So as you can see just now, sometimes you want to assign a variable to itself. So instead of typing result equals result plus 3, you can type result plus equals to 3, and it accomplishes the same thing. So it's just a shorter way to type. And here's an exercise for you guys to do. Triply added. Try to create a program that stores 3 numbers in separate variables, then uses shorthand operators, so shorthand operators like this, to add them up and print out the result. So for this, you can use your idle document instead of your idle shell. And I'll give you guys like 2 minutes to do this. Shorthand operators is just like your normal symbol and with an equals. So instead of result equals result plus 3, you do result plus equals to 3. You can take a screenshot of the shorthand operators if you want now. Try out this exercise. And here is an example of what you can do. So firstly, we create the three variables. Variable 1 equals 3. And then variable 2 equals 5. Variable 3 equals 3. And then you just add variable 2 to variable 1. Using the shorthand operators, you just write variable 1 plus equals to variable 2. And this adds variable 2 to variable 1. And you do the same with variable 3. So variable 1 plus equals 3. And in the end, you have added up all of like variable 1 to 3 together in variable 1. And as a result, 5 plus 3 plus 6 equals to 14, which is what's in your variable 1. And here is another exercise, triply added now with input. So if you recall earlier, we showed you an input function, or like how to get the user input. I think it was here. So this is how you get user input. You can just type input bracket your text. And then the input function will return you the value of what the user typed. So use the input function, and I'll go back to the exercise. Okay, so I hope that you guys have tried to do this. So you can just type input to type the first number, input, type the second number. And yeah, input will return you like what the user types in the shell. So you can just get the variables like this. And variable 1 plus variable 2 is the same thing as previously. And this is the output that you seem to get. But wait, that doesn't make sense, right? How come 3 plus 5 plus 6 becomes 356? And this is what we'll be exploring in the next chapter, which is about types. So now I'll be passing the time to Zion to do the next chapter about types.
What's up? Oh wait, let me open my slides. I don't believe in using slides. So I like to just show you like what's actually going on. Why did I open cosmology? Okay. So you guys can see me, hear me all right? Okay, cool. So we were at slide number 44. Yes. Okay, so what are types? So types are basically data types, right? And they can be like stuff like integers, floats, booleans, strings, lists, and functions. So why do types exist, right? It's because a computer really just holds its information in bytes, zeros, or ones, and these types provide us a useful abstraction that we can work with. So there are two numeric types in Python, that being int and float, right? So an integer is just like an integer value with no floating point. So like 5 or 6 are both integer types, right? And there are also floats, which are stuff like 6.5 or 6.3239100830. Yeah. So the floats are for floating point numbers or numbers with a decimal point, and integers are for numbers with no decimal point. So if you want to query the type of something, you can just use the inbuilt type function in Python. So for example, type of 5 is an integer, but type of 5.4 is a float. So yeah. Then so the thing with float and integers is that they can do arithmetic together, even though they're different types. So for example, I can add a float to an integer, and it will return a float. There's also division, right? So for example, if I take 4 divided by 6, both are integers, but I get a float as the return because they are both it automatically casts it as a float type. And this is called implicit casting because it's integer and integer, but instead of returning an integer when you divide, it returns a float, right? Which is kind of, I guess, intuitive, but counterintuitive in a programming sense. Because normally you think that, oh, if I have two types as an input to a function, I should two of the same types as an input to a function, it should return that type. But in Python, there's this thing called implicit casting, where if I take in two integers and make them such that their output will be a float in like mathematical terms, right? It'll also give a float in the programming terms, right? Now, floats are interesting. For example, because of how computers store values, right? If I do something like 1.2 minus 1.0, I won't get 0.2. I'll get 0.1999996 to some degree of precision. And the reason why it's like this is because of how computers store floating point numbers. If you want to learn more about it, you can check out the IEEE 754 standard, but that's out of syllabus. But essentially, computers can't store floating point numbers to a certain accuracy, which is why they are held like this, right? So now those are the two numeric types. Now I'm going to go on to the Boolean. So the Boolean can be either true or false, and therefore conditional types. So a Boolean will return when we do any kind of comparison. So for example, if I do 5 equals, so comparison in Python is done with a double equal sign because one equal is used to assign. So if I do 5 equal 5, it'll return true. And the two Boolean types are true or false, right? And they have some simple operations associated with them. For example, the negation operation or the not operation. So if I do not true, it'll return false. If I return not false, wait, sorry, I typed false wrongly. Not false, it'll return true, right? There's also the AND operation. So how AND works is that if both, if it's true and true, if condition 1 and condition 2 are both true, it'll return true. So for example, true and true will return true, but true and false will return false. So if you have done logic in your school, you'll probably already know this. But essentially, both this value and this value have to be true for the AND operator to return true. So for example, if I do false and false, of course it won't work because both are false. But if I do false and true, it would still not work because one of them is false. So that's the AND operator. Now so basically condition 1 and condition 2 have to be true, and that's how you can satisfy the AND condition. Now there's also the OR condition. So for example, true or true will return true because either or have to be true. So for example, if I do true or false, right, it'll still return true because one of the conditions is true. But if I do false or false, right, it'll just return false because neither of the conditions are true. Yeah. And you can join as many of these statements together to get complex Boolean expressions. Yeah. So this also brings us to the XOR and the XNOR operator, which is basically the equal and the not equal sign. So for example, true equals to true, right, will return true because both are true, because true is equal to true, right? But false will also this will also return true because false is equal to false. However, this will not return true uh, because true and false are not the same thing. So that's what XOR. That's what you call XNOR or logical equal, right? Now there's also logical not equal, and that is XOR or exclusive OR. So for example, if I say true not equal to false, right, this will return true. And in Python, not equal is exclamation point equal. Yeah. So if I do false not equal false, because false is equal to false, false not equal false will return false. So yeah, I guess that's a bit confusing semantics, but essentially all you have to know is that not changes the true to false and false to true, and it has to be both conditions to be true for it to be and true. So for example, true and true both have to be true. For or, only one of them has to be true. For equal, both of them have, or XOR, for equal or XNOR, both of them have to be the same. And for XOR or not equal, both have to be different. Yeah. Sorry if that was a bit fast. It's very simple. Yeah, you can just like mull over it for a second. It's quite intuitive. Here's the truth table. I'll let you guys soak it in. Yeah, and this is XOR. Okay, so now that we know about numeric types and Boolean types, let's go on to strings. So as you saw, we used the string "hello world" at the start of this presentation. So we printed "hello world," and a string is basically like a sentence or a word, or basically like a series of characters. So a string can be initialized in two ways, either with double quotation marks or single quotation marks. It doesn't matter. It can also be done with now, like you may be asking, what happens if I want to have a single quotation mark or a double quotation mark in my string itself, right? Well, let's say I want like a single quotation mark. I can use my double quotation mark as my string boundaries, and that way I can have single quotation marks in my string, right? For example, here Alex is, right? I have the single quotation mark in the double quotation mark. Now let's say I want both, right? I can use this operation called the backslash, right? Which basically lets me put anything I want in front of it, and I'll ignore its effects on the string. For example, I can type Alex backslash single quotation mark S. This backslash indicates to the Python interpreter that, hey, ignore this as a string declaration. It is a character, right? And then you see it will return Alex's normally. So yeah. And if you want a backslash, it's just use double backslash. So yeah. It just prints like this, but that just means a single backslash. Yeah. So now strings can have an interesting property, which is why we saw the result with the input problem earlier, right? Is that when you add strings together, they just they concatenate. So, for example, if I add strings Alex and 22133 together, they concatenate. And if I multiply strings, they just concatenate 5 times, or concatenate how many times ever I multiply it with, right? So that's why we were seeing the problem earlier, because when you take an input of something, right, like input, whatever, and I type in whatever input, you see that it returns it as a string and not as an integer type, which is why we had this problem. And this is why it brings us to explicit casting, right? So sometimes you want to convert between a string and an int, but we'll cover that later. I'll first go into the details of string first. So strings have this thing called indexing, where you want to carry access a character from the string. So Python is a zero indexed language, and I think all programming languages are zero indexed. So the first character is actually the zeroed index. So if I have a string here, char xt, I'll just store it into a variable right now, x. Uh, Wait, sorry, I typed it wrongly. Mistake. Okay, yeah. So if I have this variable string here, x, right, I can access the first character by putting x0, right? And that gives me the first character of the string, right? I can also access the second character by 1, and so on. So that's how character accessing works, right? I can also do it backwards. So for example, but backwards it's one index. So for example, if I want to take the last character in the string, I would do x -1, right? And it will return e, right? Because e is the last character in the string. If I want the second last character, I can take x -2. Yeah. So that's how character indexing works in Python, right? So there's also this idea called string slicing. Let's say instead of just the string, I want a range in the string, or a range of characters. So I want racks in charax tree, right? So how ranges work is I can do x start colon stop. So whatever the start value is where I want to start the string. So for example, 1, 2, 3, 4. It's the fourth character in the string r. So I'll put it as 3, right? And then x is the last kind of thing, 3, 4, 5. It's the fifth position. Now the stop is actually not inclusive. So you can think of it as like start, comma, stop in math, right? The stop is not inclusive. So we put one more character than the actual character we want. So even though x is in the fifth index position, right, we put 6 because the 6 is not included, but the 3 is. So if I put 3:6, I'll get Rex because it gives the 3, 4th, and 5th character, right? So that's how string slicing works in Python, right? Now let's say I want every second character in a string, right? I could then do something like I can and then do it like this. I can say start, stop, and step. So how much do I want to step by each one? For example, if I want A, right, I can set my start to be once again 0 because I want to start from the first character. Okay, I can set my stop to be X because I don't want to go anything after X. So that's 1, 2, 3, 4, 5, 6. So it's the 5th index. And then I can set my step to any number. But in this case, I want every second number. So I pick 2. So by default, the step is 1 or the next character. But here we specify the step. So you see we get CAA because it goes C, then the next letter A, then the next letter A, right? So that's the beauty. So essentially, just remember that it's start, stop, step. And the stop is non-inclusive. The start is inclusive, right? So this brings us to, uh, but if you don't want to like, you can. There's also a shortcut that you can use. Like, let's say I don't want to ignore the first character, or I know the first character is going to be just the first character, and I know the last character is just going to be the last character. I can actually leave it blank. So for example, in this case right here, right, it's already 0, so I can just like leave a blank and put :5:2. I don't have to put 0 there. Yeah. So x:5:2 will return the same result. And if let's say I have it implicitly towards the end of the string, right, I could just put x3 colon blank, and that will just read onwards from the third character to the end of the string. So yeah. So because of this stepping, you can do some really interesting things. For example, if I want to reverse the string, I could do x:(-1), okay, where it counts backwards. The step is backwards, right? So in that way, I reverse the string. Now that's a bit more technically advanced. So I say try to understand the crux of string and anything before you try to play around with negative values. But yeah. So that's the beauty of string slicing in Python. No other languages uses this, so that's kind of cool that Python has it. Yeah. So now that we're on to string slicing, we can move on to the none. There's an exercise that you guys can do for the string slicing. So look at this message here. I'm gonna give you guys 2 to 3 minutes. Can you guys figure out what this message is? Yeah. Okay, so you guys should have figured it out by now. Essentially, it'll return Python cool. And the reason because of this is because it starts at 1 up till 17, and then it jumps by 3 each time. So P, then Y, then T, then H, then O, then N. And then because we ended by the 17 character here, it doesn't jump any further, right? Then this last text 3 : 5, right? We are just going C, then I jump by 5, O, then I jump by 5, O, then I jump by 5, L. And then the next jump by 5 is outside of the string boundary, so it just stops. So that's how we get Python cool, right? So strings are, you can use strings to put like, I don't know, some secret message in it. But essentially that's the idea behind string slicing. Now, there's also a type for nothing, and that's called the null type. And it's basically what returns when a function doesn't have an output. So example, if I take this here, this function here, print hello world, right, and I store it in a variable, you see it prints the hello world right here. It duplicated the statement because that's how this compiler works. But essentially, it prints the hello world. But if you take this x type, you see it returns nothing in the shell. Right now, if I query the type with the type function, right, type x, right? Wait. It says x is not defined, right? And that's because we didn't. Yeah. Wait. Sorry. I think there's an error. Yeah. I don't know why that happened. Okay. Anyway, so you see when I called x equals print hello world, right? It printed hello world, and when I queried the type, right, it gave class none type because it doesn't have anything in it. Yeah, and that is what the none type is. It basically means there's nothing there. It's not 0, it's not false, it's nothing. Yeah. So this can bring us back to exercise 3.2, and which I was talking about typecasting, right? So what I was talking about slightly a bit earlier, right, is that we don't have in Python we have 2 kinds of typecasting: implicit and explicit typecasting. So an example of implicit typecasting was when you take float integer by an integer divided by integer, it returns a float, right? Or yeah, so that's implicit typecasting because it's implicitly, without us asking it to, it's changing the number for us. Now there's also explicit typecasting. Now that's when we are forcing it to change from one type to another. For example, if I have this number here, 5.0, if I query the type of 5.0, right, of course it'll return float. But I can convert it with, I can explicitly convert it or explicitly typecast it into an integer with the int command. So int 5.0 will give 5. And if I query this, right, it'll give me an integer type. So that's explicit typecasting. Effectively, you're changing things to different things. So for example, if I put my 5 into a string here, right, it would give me an integer 5 instead of the string 5. And that was the problem with the input we had earlier, right? When we call the input function, right, and we typed in our number 3, you see it would give us the string tree instead of the integer tree. And you see how strings work. When I told you, when they add, they concatenate. They don't add like in math terms. So that's why you have to convert the input into an int for it to work. So now, knowing this information about explicit typecasting, right? Uh, you should try. You could try some basic examples of it. So essentially, for converting to an int, you can try bool. For converting to converting to a boolean, you can try bool. For converting to an int, you can try int. For converting to a float, you can use the float. Now, do note that some of these have errors. For example, if I type int and I put something that's not a number, right? Obviously, it can't convert that to an int with base 10 because this is not integer, right? Same way, if I try to do it on a float of a string type, wait, that was a bad example. Yeah, it would not return because you can't convert a string to a float that's not defined as a float, right? So that's why you have to be aware. But the thing is, there's also this bool thing for converting to a boolean, right? Now this works slightly interestingly. So I want you guys to try it out and test it out and see what it returns for different values. Yeah. So I'll give you guys 1 or 2 minutes to try it out. Yeah. Okay, I think that should have given you enough time to try. If you didn't try, it's also okay. I'll just show you now. So the boolean works in an interesting way. It converts anything that's 0 to false and anything else to true. So for example, bool 0, bool 9, bool 0 will return false, but bool 9, bool -5, bool 0.9 is all all of these are true, but bool 0.0 or bool 0 is false. So yeah, that's how boolean works. Anything that's for float or ints. Right, now you have to be careful, right, when you're doing a boolean to float conversion, because I told you about float rounding, right? So if I do 1.2 minus 1.0 minus 0.2, right? I'll get like, I won't get this, I'll get a value very, very close to 0, but not 0 because of how float rounding works, right? So if I try to call this again, right, it'll return true even though it's almost very close to 0. So I suggest, like, if you're converting a float to a boolean, you like do some kind of like check to make sure it's within a range, which I'll show you how to do later. But yeah. So that's just one thing to remember. And then for string, if it's empty, it'll return false. If it's true, it'll return. If it has something in it, it'll return true, right? So knowing what you know now about typecasting, right? Can you guys redo the triply add with the correct cast? Yeah. So I'll give you guys 2 minutes to this. It's just a slight modification of the earlier code. Yeah. Oh yeah, also reminder, if you guys are have any questions, please use the ticket system on Discord. Yes. Okay. So now that we are done, I mean, now I hope you guys have tried it. So let's go look at the solution. So you see that instead of the previous solution last time where we just took in the input, this time we cast it into a float type, right? and then we do our addition. Yeah. So all the difference between this and earlier was just this float mention, this mention of float. Yeah. Okay. So now you probably understood the idea of floats. I'll once again go through them because there were some complaints that I was too fast. Uh, I went through booleans quite fast because we're about to cover them again. But essentially, there's the integer, which is any like number that doesn't have a floating point. There's the float, which is a number with a floating point. There's a string, which is just a sequence of characters. There's the boolean, which is a value which is true or false. And the boolean has some operation which is AND, which is true and true will return true. Basically, in AND, both this and this have to be true for it to return true. And there's also OR, in which either or condition 1 or condition 2 have to be correct for it to return. Then there was NOT, which converts it, which is a unary operator, and it just switches true to false. And then there's true, and then there's also XOR, which is true not equal to false. So basically, both of these have to be different for it to return true. And then there was XNOR, which is true, which is equal, which basically both have to be the same. Yeah. So that's idea of types. Now on to our next topic, which is conditionals. So I think you've understood by now that the Python control flow is downwards, right? If I'm writing code in Python, it'll do line 3 first, then it'll do line 4, right? Then I'll do line 5 and so on and so forth. So the Python control flow is downwards. But in certain cases, you have to alter that control flow based on the situation that you're given. And that's why you need something called conditionals. Under certain conditions, you want something to happen. Under a different condition, you want different things to happen. So for example, in this case here, if a given condition X is false, I want it to go back to task 2. But if it's true, I want it to go to task 3. Yeah. So this brings us to the condition operators, and the reason now you can understand the reason why we have booleans. Booleans are just the raw form of the condition operator. So if I do 5 equals to 5, as I told you earlier, right? 5 is equal to 5. So therefore, it will be in the form true. So basically, when you evaluate a condition, it will return a Boolean value true or false. And if that is true or if that is false, we'll change the control flow of the program, right? So there are a few comparison operators. There's equal, which is equals to. So as I showed right now, so if a value is equal to something, it'll return true. Next, there's not equal to, right? So if, for example, 3 is not equal to 4, obviously this will be true because 3 is not equal to 4, right? But if I say 3 not equal to 3, this will be false because 3 and 3 are the same. Yeah. There's also more than or equal to, less than or equal to. Now, in Python, you can also chain these conditionals. So for example, I say true and true and false, right? It'll return false because this will evaluate to true, and then this will evaluate to false. Now, you need to be very careful when you chain conditionals. In fact, I suggest you guys use brackets for your own safety, right? You can't also do something like if x equals to 5, x equals to 4. I can't do 3 comma x smaller than 5 like in math, because what's going to happen is that it's going to evaluate this 3 smaller than x as true, and then your question will be, is true smaller than 5? Which is incorrect. So if you want to do something like 3 smaller than x smaller than 5, right? We can check like this. We can put 3 smaller than x, and x has to be smaller than 5. So yeah, just make sure to do that. So your and or can allow us to join conditionals together based on the way we want them to handle, right? So yeah, so that's what we used and or for earlier. Yeah. So this is back to Boolean and recap, so it can help us understand conditionals better. And that's essentially the Boolean is the evaluation of the conditional. Yeah. Note also for more equal to, there's no operator on it. You just put greater equal, like just literally put a greater sign than an equal sign. And then for less than or equal to, it's a less than or an equal sign. Yeah. So now there's also an interesting, the Boolean is what returns the thing. And a Boolean's value is basically kind of like 1 or 0. It's like the same thing as conditionals. Uh, so this is an example of implicit typecasting. Or like not exactly implicit typecasting, but essentially Booleans can be compared with numbers. But I suggest you don't do this because it makes your code hard to read, but you can do it, yeah. So a false is equal to a 0 and a true is equal to a 1 in technical terms, but you don't have to know about it. Or there's also the in function for checking whether something is in a string. For example, if bruh is in bruh, right? This will return true because this short string is inside this substring is inside the bigger string. Yeah. So there's also not in. So for example, if x is not in, wait, sorry. Get this 1 second. If x is not in, I don't know what's a word without x, water, right? This will return true because water is not, x is not in the string water. Yeah. So that's in and not in. Yeah. So now this brings us to an if statement, how we can actually change the control flow. So if let's say I have some variable x, right? X equals whatever input, or no, I'll just put it as 5 for now, right? If this x value is greater than a certain amount, right? 3, for example, I wanted to print a, right? But so this is how a conditional if statement works. So if you put if, right? Sorry, I don't need the brackets. It's a force of habit because you need it in other languages. But if some condition is met, then print yay, right? Now, as I told you, right, Booleans are the raw evaluation of a conditional, right? So if I put if true, this will just return, this will always print yay. So it's just saying that if true, but if I put if false, right, it will never print yay because it'll always evaluate to false. That Boolean condition will always evaluate to false, so it'll return, it'll never do the condition. So if x is greater than 5, this is false because x is 5 right now. It will print yay. So if I try to run it right now, you see that it will not print anything because I didn't ask it to, but because 5 is not greater than 5. But if I change to 6, 6 is definitely greater than 5. So it will print yay. Yeah. And that's the idea of if statement. So if a conditional is met, then you do that. And the reason is, you see here, I put a dent, right? After the if statement. And the reason why I put a dent is because that's how Python interpreter can know what is part of the if statement and what is not. So if I put something outside of the if statement, right? Like hello word, right? The hello word is not part of this if statement. So if I make it in a condition that doesn't fit, like x equals 3, the hello word will still run, but the yay will not run because it's not in the if conditional. So you can separate by tabs, right? And this tab is telling the compiler that, hey, this line of code is part of the if statement. This line of code is not, right? So then, like, let's say, oh, if it's greater than 5, but it also has to be, but also if it's smaller than 5, I want to do something else, right? I can use the statement called else, right? Uh, Pretty intuitive. So if x equals 5, print yay. But if x is smaller than 5, print nay, right? Uh, so now, if this condition is met, it'll print yay. And then the interpreter will check, oh, okay, this condition was not met. I'll move to the next one. Else, okay. Oh, wait, sorry. That's not how else works. Okay, otherwise, just print nay, right? Wait, I confused else with elif. But for now, else just doesn't have anything after it, yeah. And make sure to put the colon after your if statement. Sorry, that was a slight mistake on my part. But essentially else, right, is saying that if this condition is met, do this. Otherwise, else, just do this. Yeah. Right. Now, for the statement I confused it with, elif, right? Elif is basically else if. So else if another condition, right? So in the else if, right, is basically it checks if x greater than 5, else if x is smaller than 5, do nay. But if neither of these conditions are met, then you do the else statement. So you can add as many else if statements as you want, right? And essentially they evaluate in the order of control flow. So it'll evaluate x greater than 5, then else if x smaller than 5. So even if, like, let's say I put x greater than 4 here, if this evaluates to true, right, it will not print nay, even if this evaluates to true as well. So for example, if I put if x equals 6, right? Wait, else. Oh yeah, sorry, it's elif, not else if. Right? If I put x greater than 5, you see, right? Even though 6 is greater than 4, this already evaluated to true, and it left, and it has exited the control block, right? But it did not run this statement. So make sure you be careful when you use if and elif. Yeah. So you can add as many elif statements as you want, as I mentioned just now. Yeah, so you can add another one, if elif x has to be smaller than 10, then print whatever. Yeah. So if I put in like 4 in this control loop here, right, it'll print that. And if I put something like string, it'll return an error because you're doing a comparison on a string and not a string. Let me just change this to something else. I'm trying to show you how else works. So you see that if I put x equals to 2, none of these conditions will be satisfied. So therefore, it runs the else statement. X is 2 greater than. So this is how, if you're thinking of it in the terms of Python interpreter, I'll check if is 2 greater than 5. No, skip. Is 2 greater than 4? No, skip. Is 2 greater than 3? No, skip. Okay, I do the else statement now. Yeah. So that's if, elif, else in Python. Yeah. You can also put if statements within if statements. So for example, I could do if x greater than 5 and x is smaller than 10, then print x, right? So how the control flow works is that it assumes that if this condition is met, then okay, now we check this condition is met, then we print that. So this is where you have double indent. You have to indent twice because it's telling the compiler that, oh, this print x is part of this if statement, not this if statement. So that's why you have to double indent instead of single indent. Yeah, and it works all the same, right? It's just indented in one more. And this is called a nested if statement, right? So if else print hello. So you see 2 does not satisfy this condition here. So even though there is an else statement, the else statement will not run because this else statement is inside this if statement, right? Because we have the indent, right? So if x, so we see if we run here, it'll return nothing because x is not greater than 2. But if I put something like 15, or yeah, 15, it is greater than 5. However, it is not smaller than 10, so it'll return hello. Meanwhile, if I put something in between these two numbers, it is greater than 5 and it is smaller than 10, so print x. So yeah. So that's the idea of nested if statement. Once again, I'll go through it one more time so you guys get the idea, right? Essentially, when you're defining an if statement, you go if condition, then you have a tab, you put in your code here, and then if you want outside of the if statement, you can do your other code, and that's how if works. You can also have elif when you have another condition. And you can also have else, which is the condition that evaluates when everything else is false. And note that even if condition 2 is true, if condition 1 is also true, condition 1's code will run first. And then even if condition 2 is also true, but if condition 1's code is already running, condition 2's code will not run. So yeah, just make sure you know that. Yes. So now we're gonna do a practice with nested if statements. Based on these conditions here, can you guys write if statement that works with this kind of input? So for the input, just use user input. So x. Wait, I once again made the else mistake. Sorry, else has no condition attached to it. Why do I keep making that mistake? I'm so sorry. Okay, pretend there's nothing here. Yeah, there's no condition in else. Else is just what runs when nothing else is correct. Yeah. God, I'm so stupid. Okay. Uh, yeah. So for this task, you take in user input like the standard way. Yeah, just use input. Yeah. So try out this task. Yeah, I'll give you guys 3 minutes for this one because it's okay, I'll give you guys like 20 more seconds. I think it's enough time. Even if you guys didn't like code out the full thing, I hope you guys got an idea in your head of how it works. So essentially, you take in the input number and the input letter, right? And then if the input number is less than 3, uh, you just do the conditions as said in the table. So if it's A, then you print 1. If it's B, then you print 2. If it's C or it's L or it's D, print 3, else print 4. And then you just follow all the conditions in the table. So as I said, you just do nested if statements. So if this condition first is met, then you run all of this. If this condition is met, you run all of this. If this condition is met, then you run all of this. Or you run the other if block. So yeah. So this is like the bare bones way of writing. Of course, there's more efficient way of writing, which I'll show here, right? So you see how I could simplify all of this or statements into just checking whether it's in CDE, like that. Now, of course, this technically kind of simplifies the code in a way where you could get incorrect result. So if I took my input as CD, it would still return this as true because CD is still part of CDE, right? But because you said input a letter, right, it's fit for purpose, it's fit for this function, it would still work correctly if given the correct inputs. Yeah, and that is your job as a programmer. So yeah, so the in statement does obfuscate the true answer bit, and this is not exactly what the table is asking us to do it, but it's a simplification we can make. Yeah. We can also make the code a lot shorter by observing patterns in the nested if statement. So if you understood that how this thing was, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they all have this pattern associated with them. So if n smaller than 3, it's just a different starting value based on it. So it's 0 if it's A, it's 0 if this is this, if it's 4 if it's this, if it's 8 if it's this, right? So that's the idea behind the nested ifs, right? And you can simplify it further by viewing patterns in our if statements. Now, I don't expect you guys to do this. In fact, this is also obfuscating the code a bit, but yeah, that's how it can work. So you see that I don't have to check 3 is smaller than n and n is smaller than 5 because if this condition has already failed, we know that it's definitely greater or equal to 3. So therefore, when we call the elif, we can just check whether it's smaller than 5. Yeah, and that's the idea behind if statements. Now, because it's a bit more complex, we'll give you a second exercise called guess the number. So store a 4-digit number in a variable, and now create an interface for a player to guess the number. Now, if the sequence of digits is inside the input or inside the answer, output inside. And if it's exactly the same as the number, output right number. So for this, you have to make use of the in and not in statements that I used earlier. So just check that out. Yes. I'll give like 2 minutes for this because uh, I don't think you need to go through it fully. Yeah. Okay, so since we're running out of time, I'll just go through this fast. Actually, I don't think we're running out of time, but in the interest of time, Yeah. So essentially, here's how it works: is if the answer is equal to some 4-digit number, I can guess the input, and now I can check that elif guess is in string answer. I print inside. Now you see the answer is an integer, so I have to cast it to a string, so I can use the string function. Yeah. So if I enter input 6, 6 is inside 5, 6, 7, 8, so it says inside. And if I put 67, it's inside 5, 6, 7, 8, so I put inside. If I put 34, it's not inside, so it doesn't print anything because it just exits the control block. And if I put 5, 6, 7, 8, it is the correct number. So yeah. So you see, if I had reordered it such that the in statement was before the equal statement, my code would not run correctly because the 5, 6, 7, 8 would be correct and it would put the in and it would print inside first. And then, as I said, the next value in the control block is ignored. So yeah. So now that you've understood conditionals, I'll go to the last section of my part, which is functions. So what are functions? So as I explained to you guys, Python has a downward control flow, right? But sometimes you have repeated operations which you want to simplify. So for example, if I have like, if I want to print like a number and it's like the next two numbers of it, so print 2, print 3, right? And then for the number 11, I want to print the next two numbers as well. Yeah. So if I run this, if I keep having the need to print these things, I could store it in something called a function, right? And a function is basically a stored procedure or something that I can refer to with inputs and outputs, right? So as I said, print is one of the function, and the input for print is like this, and the output for print is nothing, right? So I can define a function like this with the def, and then the function name, and then a close bracket, open close bracket, colon, and then once again, I'm using indents for my code to indicate that this code is part of this function. So example, functions can have arguments as well. So for example, the arguments go here, all right? And then based on these arguments, I can do what I want. So if I want to implement like this function here, right? It's only one argument, right? The argument can be of any type, and also the argument can be different from whatever operation you have in the function. So for example, I want to do this thing where I print the first value, then the next value, and the value after that, right? So I print arg1, print arg2, arg1 plus 1, and print arg1 plus 2. Right. So this stored procedure or this function, which I'll call uh, print tree, right? I can now replace my code blocks with this simplified version print tree. So print tree of 1 and print tree of 11. Now, functions are optional, but it's very highly suggested that you use them. It improves the modularity, adaptability, readability of your code. And it can tell, and the name of your function has to be, can tell you the meaningful thing. So for example, if I see print 3, I can say, oh, okay, it's going to print the next 3 numbers. So you see, this gives the same output as what I gave earlier, because this print tree calls it, takes this 11 as the argument, and then uses it for the function. Now, as I said earlier, right, you can use this argument as anything. So like, let's say I want to modify this function, that instead of printing the next 3, it prints the next 3 multiples, right? So I can do print arg1, print arg1 plus arg1, and print arg1 plus arg1 plus arg1. So for example, 1, 2, 3, 11, 22, 33, right? Now I can use this print tree. Because this behavior is still valid for strings, I could use this print tree for strings as well. So print tree, and I could feed in a string value like bruh, right? And you see, give me bruh, 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 bruh. Yeah. So that's the idea of a function, right? Functions can help us modularize the code, right? Now you can also have functions that return things, right? For example, the famous function that returns things are like your standard slash. There's special kinds of functions, but they're functions nonetheless. But example of someone would be float or int or any kind of cast, right? When we take the float of it, it returns this output 5.0, right? So you see this print tree will normally return a none type because there's no thing. But if I use float, right, I can store that value in a variable. So x equals float of 5.0 or 5. So it's converting this 5 to an integer, and 5.0 will be stored in x, right, instead of a none type. And I can print this x here, and yeah, you see I got 5.0. So that's the idea of function that return. But how do you define it in code? So def function name, and then you can have arguments, right? And then you define your output by using the return statement. So return arg1 times 6, and we call this function times 6, right? So if I take x times 6, right, of 5, right, and I print x, 5 times 6 is 30, so it'll return 30. Yeah. So the return function is used, I think. Now, functions have a few quirks that go along with them because of how they work. For example, if I have a variable outside the function and a variable with the same name as a variable used in the function. For example, if I had num5, right? Right? This function will automatically use this variable outside defining the function, right? So it'll return 10 because 5 plus 5 is 10, right? Now, here's the interesting thing. If I define num inside my function itself, right? For example, 3, right? This function is going to prioritize its use of local variables over the variable outside the defined. Now, this is called local and global context. Essentially, this variable is in this function, so it's going to take precedence over anything outside that function. Now, also do note that I can't call variables that are defined in functions. So, for example, num3 is defined in this function. I can't call num in the function because num is not defined. All variables used and created in the function are automatically destroyed once the function once function call is over. So I can't use variables that are defined in functions. Yeah. So ideally, you want your function name, the name of the variables in your functions to be different from those outside of its scope because you don't want confusion for the reader and confusion for the interpreter. So yeah. So now we're gonna try. Oh wait, it gave you the output anyway, but sure. But you can look at this code here. If I define num1 equal to 7, and then func1 of num1 equals num plus equals 2, print num1 and num2, print num1, call func1
Yeah.
num. So you see in this code right here, if I write it out, num1 equals 7, def function
Yeah.
num num1 equals num plus equals 2, and then print num1 print num. So if I print num1 before this function is called, right, it's not changing num1, so it'll return 7, right? When I call this function with whatever number I want to change it to, let's say 3 in this case, right? And I print num1 again, it's going to print it's going to change it's not going to change this num1 defined outside of the scope. It's going to change this internal num1 which is different from this num1. So even though they have the same name, the function will not change the external outside variable. Yeah. So you see this num1 associates with this 7, and this num1 associates with this 7 here. So a function cannot change a global variable that is assigned to it, because what the function will do is just create another variable num1 and assign that to it. It will not change the global variable. Now, please make sure you take note of this, because this is a very important thing. You can deal to a lot of problems down the line if you don't account for this. So yeah, just know that you can't change a function outside of the scope. Yeah, of the function. So change it within the outside the scope of the function. Don't change it inside the scope of the function, because it won't work. So yeah, I'll recover the return statement. Here's an example of a more complex function. So in this case, it's round to nearest, num comma nearest. So here I put an if block in the function, and this just shows you that you can put any kind of statement within function. Yeah, except yeah, no, actually yeah, you can put any kind of statement within the function, and yeah. Do note that for return, right, the execution stops when you call return. So if I have a def function here, 1, right, and I say I have argument 1, and this argument will just return argument times 5, right? If I put anything after it, right, this code right here won't run. This print 5 won't run, because the return terminates the function. So for example, if I call function 1 here, function 1, right? It won't print anything because the execution stops here. And same if I put it in an if statement. So if arg1 is greater than 3, right? Then I put a return statement within it, right? Only if it's greater than 3 will it, if I put a value in that's greater than 3, right, it will return nothing because I'm not printing this value, right? But if I put in a value smaller than 3, right, this will not return here, and then it will print the 5. So the moment the function calls, what do you call it? The moment the function calls return, the execution stops, regardless of anything else is after it. Yeah. And if you don't call return, then the execution continues. So yeah, just know that about return. So in this case, if the remainder is greater or equal than nearest over 2, then you return it. So this return will not run anyway. But if this condition fails, then this smaller, lower return statement will return. Yeah. So now here's exercise 6.2 for you guys to try out. One of the last exercises for this my section. So write a function that takes in 3 numbers and outputs the number with the highest value. Yeah. So basically a max function. Find the max of 3 numbers. Yeah. I'll give you guys 2 minutes to do this. It's a very fun exercise, so try it. Okay, so I hope that was enough time for you guys to quickly draft something out from the knowledge you know. So here's how you do it. So if the maximum if the highest is equal to we can first assign some variable highest to the first number. Then if the second number is bigger, we put highest. We call the highest, and if the third number is bigger, then we make that the highest. And then we return what the highest value is. Yeah, it's a very simple function. So yeah. So you could also return more than one value in a function, but it's just, so if I can return it like this, return uh, and you separate the outputs by using commas. So arg1 times 2 comma arg2 times 3. So when I call the function right here, I can store it in 2 different values. So x equals y, x comma y. I can put function 1, 2 comma. So that's how functions can return 2 values or with the return. So for example, I wrote this function split the string at an index, right? And yeah, I could split S1 and S2 like this. Yeah. So so do note that to be very careful when you do this, because if there's, let's say, you can't put 3 values on this side if we know that this is going to output 2. So make sure to be careful when you do your return values. Yeah. So it actually is returned in this special class called a tuple, which is like kind of like a list, but we'll cover that later. Yeah, you don't have to know much about it. Just it's like it's a structure which contains all the outputs, but you don't have to know about it. There are also built-in functions in Python that you probably like abs and round. So you should ideally use built-in functions over your own defined functions. I think is max in the standard Python library? I don't think so. Oh, it is. Yeah. So you see the max function you worked on right now. I could just use the built-in Python's max function. So 43, whatever. Yeah. So sometimes don't rush to always write your own functions. Use built-in functions. In fact, it's a design goal to always use your built-in functions over your own defined one. It's because when you define your own function, you have to explain how it works to someone reading your code. But if you have use a built-in function, someone who already knows the language already knows what that built-in function is doing. And that's why it's a good programming practice to always use built-in functions. Now, I'll give you guys a 5-minute break slash Q&A, and then I'll move it over to Pranay to talk about loops. So, Pranay, take it away.
Okay, hello. Let's start talking about the more, I guess, complex stuff now that you guys have covered functions and conditionals. So, at least in the general flow of Python, I guess I'll cover the control flow first. So, I guess currently Zion has already told you about conditionals and how they apply to our control flow in any process that we need to create. So for example, in a normal task, you will have that task one goes to task two, goes to task three, and it progresses linearly. But the problem is that sometimes you want specific tasks to be skipped if, for example, some condition is true. So for example, if you're considering for NS checkup, right? Or IPD, for instance, then if the person is obese, then the person shouldn't be needed to take IPPT because they're already obese, so they already have to go for the extended BMT. So the logic why that is just like you skip the entire step of IPPT and go directly to NS. So that would be a conditional. On the other hand, you also have this other concept of repeating one specific process over and over again. And currently, I guess based on what you've learned, you'll basically just like copy the code over and over again if you want to repeat it. But there is a better way of doing that in Python. And I guess that's the point of this chapter. So essentially, if you want to print hello 5 times, you have a choice of just copying all of the line continuously 5 times, or you can just do something else compared to this. So an example of what you can do is you can use either a while loop or a for loop. So these are two types of loops in Python that are very important because essentially they dictate, they allow you to do specific things, and they're very different in the sense that for is, I guess, more gated compared to while. Like it's more defined. So I guess for now, don't worry about the syntax. We'll first cover like more of the basic notation behind while, and then we'll go to for. So yeah. So for while loops, basically it's like an if statement, but after the if block runs, it will come back to the loop and check again. So for instance, if for example you were doing this, and then you added you increase the number itself, right? If you run this entire like block of code once, but in a while statement, what it does is it runs this code, then it goes back here to see if the condition keeps matching, so it keeps going and keeps going and keeps going. And once the condition fails, it will break out of it and it will run the sprint number, which is why you'll see the while block being run 3 times because it goes from 0 to 1, 1 to 2, and then from 2 to 3. And then once it gets to 3, it breaks. So that's how a while loop works, I guess, if I had to simplify it. So one problem that you might encounter in while loops is infinite loops. And infinite loops is basically where you set the condition such that every time it loops back, it's always going to be true. That means that you're not editing the constraint in any way. And the problem with this is that when you run this, it will keep printing this while block, and it won't even print stop. So it will just continue keep printing it. So if you want to test it out, you can test it out. But if you want to test it out, please press Control C when you stop running the code, because Yeah, it's a huge spam because Python can run a lot of instructions in a single second. Okay, so I'll leave you guys to do that if you want. So we'll just move to the next point. So basically, an infinite loop just happens where you just have the condition being true every single time. You're not changing anything, you're not editing anything, and nothing's really happening, I guess, if that makes any sense. Yeah. So I guess beyond this, what you need to remember is that if the condition is always false, then it won't even run the loop. It will just keep past the loop. And that's another thing that you need to note. So you need to make sure that your condition is true when you're starting the loop, but you also need to make sure that the condition is false when you're ending the loop. So yeah, I guess that simplifies it. So for now, let's move on to an exercise, which is exercise 7.1, multiple guesses. Basically, as Zion had covered, you basically needed to get the user to guess a number, and then it will tell you if the number is inside the actual number, like through string manipulation. So for now, what I want you to do is try to implement this in a while loop. Just try, I guess. Yeah. I'll leave you guys to do this over the next 2 minutes or 3 minutes. Yeah. Okay, yeah. So I this is basically the solution to the question. And essentially what you need to do is just like change the if statement to a while, and you keep going through the entire loop until they give you a proper response. Yeah. Okay, so beyond this, something that you need to remember is also the range function. And the range function deals with essentially generating a sequence of numbers. Like, for instance, if you want to go from count from 1 to 10, then you can use the range function to do so. You don't need to hard code 0, 1, 2, 3, 4, and so on and so forth. So the method to do that is you can use the function itself. And the function has three main modes. You can either input one variable and it will just go from 0 up till that variable, but it won't take that variable in. So for example, if I did range of 5, it would be 0, 1, 2, 3, 4. Or if I were to do range of 20, it would be 0 all the way until 19. Then if you give two arguments, it will also establish a lower bound. So for that, what you can do is, for example, you can count from 1 to 10 via 1 comma 11, or you can count from 1 to 20 via 1 comma 21. And if you count from 1 to 5, if you do range 1 to 5, you'll get 1 to 3 4. Yeah. So with three arguments, it's very different because you essentially have the step notation, and that allows you to take like a step, like it adds two values over and over again until it reaches the upper bound, and that's another power of range function. But do note that the range function in itself does not create this thing called a list, and you will actually have to create the list yourself via calling this list function, or rather the class. But yeah. So let's now get to for loops. So for loops essentially use stuff like ranges and any form of iterable to do exactly what you're suggesting here, and they're used to effectively like um just like iterate through a sequence, just look through every value in a sequence, and it can execute any block of code over a value taken from that sequence. So for example, it can take each I from that value from the range list, and it will just print that value, and then that will just print 0, then print 1, then print 2, and that's how that works out, I guess. So syntax of a for loop is basically just you have a for, then you have a variable declaration. You can declare a variable here. Then in, and then your list iterable anything. You can put a string, you can put a list, anything. And then you have the code block. So remember that you also need to indent your code. Same for the while loop and the if statement. And you need to use the colon now. So that's it. Okay, so next let's get to the second exercise, which is exercise 7.2, which is to define a function that prints all the even numbers starting from 0, but then lower than the specific value. So you guys can try this out. It should really just take you like 2 minutes. Yeah. We'll reconvene at 12:16. So then I'll fix the thing. Okay, so it's 12:16. Let's go over it. Essentially, you just need to define a function with a bound. And the power of the bound is that you can just like do for I in range 0, bound 2, and print the value. And the reason why we have to still use the zeros because you want to use the step notation. Yeah. Then for iterating the strings, basically what you need to remember is that a string is also a iterable. And the power of that is that a for loop can just go through an iterable, right? So you can take every character of a string and print that character. So the ch means character, and essentially that allows you to print that. So now let's get to the next exercise. Yeah, there's a lot of exercises in this thing. So what you have to do is create a function that takes an integer and returns the sum of its digits. Just try it out. I think this could take longer, so I'll give you guys 4 minutes to do this. Let's reconvene at 12:21. Okay, so 21, so let's go over it. The method of this is a bit more complicated because essentially what you have to do is you have to convert it into a string and pass through that string and convert each character into an integer and return the sum. So, yeah, this method is very convoluted, and there are definitely better ways of and better and more optimized ways of doing this, but this is just to demonstrate the power of a for loop. So another thing that you need to know for loops is these two keywords known as the break and continue keyword. So the break keyword is used in loops, and essentially the idea is it immediately ends the loop when it gets reached. So like for example, if you have another condition that needs you to break out in the middle of a code block, you will probably use the break statement. So for instance, if for example you want to break out when num equals 6, but you don't want to print end of block, right, after after number 6, then you can break out right immediately after that. So essentially it will run through this print end of block. Then once it gets to num plus equals 1 and num becomes 6 and you print 6, it will just immediately break out. It won't even print this, but it will print this because this is how the control flow works. And the continuous statement, on the other hand, is the same thing if you want to skip specific points at a specific, a specific condition. So, like, if you want to skip at 6, like you want to print all numbers except 6, then you can do if I equals 6, then you continue before you print the thing. But of course, these two statements are used very sparsely in most apps because usually you should be able to come up with a better way of doing it than just running this as it is. But yeah, this is good to know at least. So now let's get to lists. So I've been mentioning a lot about lists with iterables and for loops and stuff. But what are lists in general, right? Basically, lists allow you to compile a large amount of data together into one what we call object. So that allows you to just like use one variable to denote all of them. Like instead of using crew member zero blah 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 blah, what you can do is you can make it crew members and store all of their names in that one construct. So the problem is of course that once you have like once you're like you have like 200, 300 people in the list, you cannot possibly keep doing this. This is a very bad programming practice. So that's the idea of lists. So what you can do to create lists is you just need to use square brackets and commas to essentially mask all the values. So for example, if you want to store baguette and croissant into one list, you can just separate them via commas and add square brackets at the start and the end. Then it will just store it as a list. You can also store various other types in the list, like you can store strings, you can store integers, you can store booleans, and you can even store lists inside lists. There's no limit in lists because essentially this is not a lower level is programming language. Python is very high level, so it's able to handle all of these really, really well. And you can even put existing lists within a list, which is like essentially it just goes even more crazy after that. So something you need to know, and I think this was covered when we covered, string indexing, is basically you can also slice the list via the same method. And that is, for example, you can use 3 to 7, and that will give you 3, 4, 5, 6, and it won't give you the seventh character, and so on and so forth. You can even use the negative indexing and stuff. Everything works. So iterating through it is the same thing as just like putting a string there. So you could also just put this entire list as the argument here, but I'd not suggest it. Essentially, that allows you to do all of this really, really easily. And you can also use len to get the number of elements in the list. So the len of this list is 4 because there's 4 elements A, B, C, D. And that's essentially how you can use this. Then for merging of lists, there are multiple methods that you can use to merge lists. You can use the plus statement, which is the only mathematical operator that works on lists, by the way. So birds and mammals, you can just add these two up via a plus statement, and that will store all the animals in your database. And if you want to add specific elements, you can always go back and create an entirely new list here and add it to the existing database. But sometimes people prefer if you didn't do that and you just immediately added the item into the original list. And that's the power of these two functions known as append and insert. So append allows you to essentially add the value at the end of the list, while insert allows you to insert it at a specific index. So, for example, you can insert KC right at index 2, while Erica will always be placed at the end, no matter what your list is. Yeah. So just note that this does not this if you store students if you run students.append, it returns the none type as well. Like it does not return students. So if you do students equals students.append, you will end up just losing the entire students list. So please don't do that. Yes. Next, something that you can do, which is more important, is also removing and popping of values. So removing of values is just you put just if you want to remove a value, you do not remove value. And if you want to pop a value, it's like removing an index, a value at a specific index, you can use pop. And the power of pop is that if you don't put a variable inside, it will remove the last value and will give it to you really, really quickly. So it's like the removing the item at the end of the list is perhaps one of the fastest operations in Python and in general in many other data structures. This is what we call a stack, and you don't need to know this at all, not yet at least. Okay, so now let's get to the next exercise. And it's basically defining these two functions known as print colors and print six colors. Print colors will give you the initial, the first character in each colors, and print six colors will just print the entire list without indigo. So I'll leave you guys to run this in the next 3 or 4 minutes. We'll reconvene again at 12. Okay, maybe 12:31 should be reasonable. Yeah, you go ahead. Yeah. Okay, so let's go over it. The methods are really quite easy actually. So print colors, you can just go through the entire list and print the first element of the list, first character of the element of the list. So that's okay now. For print six colors, you can do this basically, which is just slicing to remove the fifth element. Just don't use remove or pop because your original list would be modified, which means that after this, if you were to run print colors, it won't give you the eye, and that's a big problem. So that's why you should use slicing, where you can create a copy of the list. So that brings us to this concept of references, and I guess this is a bit more complicated to explain, but the idea is essentially that a reference is a reference and the actual value of the element are two very different things that are defined separately in our programming languages and stuff. So a reference points towards the value, and the value is just allocated somewhere in the memory, while the reference is allocated somewhere else in the memory. But the reference's value points towards the value's value, I guess. Yeah, the position in memory basically. So essentially, what you can do with that is that you can have multiple different references pointing towards the same exact value. So if you were to change this specific value, then all of them will change. And that's one power of references and values that you won't see with other things. So like if you were to just to take the value as it is on face value, it won't really work that well. And that's why there's this concept of shallow and deep copies. And shallow copies are essentially where you create the reference, but you're essentially creating a duplicate reference pointing towards the same value. So an example of this is if I were to do bio students equals students, what this essentially does is it stores the location in memory of this list that's already stored in students, by the way. It also stores it into bio students. So then if I were to remove Bobby from the bio students, then it will also remove it from this entire object, which means that it will also remove it from students. If that makes any sense. Like shallow copy is essentially one big issue, big mistake that people make a lot, and that's of no, I guess. A deep copy, on the other hand, is where you're essentially reallocating more space in the memory for an entire copy of the entire, this entire thing. So this allows you to essentially change and modify the copy without modifying the initial value. And that's essentially this. Yeah. Okay, so for sorting elements, you can also sort any elements. You have two functions to do that usually. You have the sort function and the sorted function, but I'll only go over the sort function. So what you can do is you can run dot sort, and we'll sort it via this thing called lexicographical order, which means that it takes the first character of everything and compares them. Then if the first character is the same, then it compares the second character, and so on and so forth. Essentially, that's the entire idea. And you can also run it on reverse, and reverse basically means that you're running it on a descending order. So these are two things that you need to remember. There's other things like there's a key variable, but honestly, you don't need to know that unless you're doing like IO related stuff, I guess. Even then, you'll probably be using C++, so why would you even care? Yeah. But yeah, so now let's get to the next exercise where essentially you have to write down the output of this code chunk. So I'll give you guys like a minute or two to try this out. Again, reconvene at 12:36. Yeah. Okay, so the easy way of looking at it is that when you do a plus operation, you're not making a shallow copy, you're making a deep copy. You're copying every single element in that list into another list. And that's one very cool thing that you can do in this, where you can essentially like remove the first value, and it won't affect, for example, it won't affect B. So if I were to, sorry, it won't affect A. So if I were to do like C0.pop1, what I'm doing is I'm essentially removing the second element of the first element, I guess, if that makes any sense. So I'm removing the 2 here, and that causes it to look like this. Then after that, when I do d.remove 910, then this 910 gets removed. And what you'll notice here is that C's 910 also gets removed. And that's because you made a shallow copy. Yeah. So beyond this, something else that you might need to know before we move on to the next point is this thing known as tuples. And tuples are very similar to lists. Like they're basically the same thing, other than the fact that tuples have a fixed length and they cannot be appended to and values in them cannot change. So they have a lot more of a restriction, and that's because they're faster. So they give away some of their privileges in exchange for speed. And tuples are used if you have a defined set that you never need to change, that you never need to add values to, you don't need to do anything to, then you can use a tuple and it would be faster for you as well. So now let's get to the last chapter thing, and I guess this will be the last of our workshop today, and that's modules and packages. So essentially, this is very important, especially since a lot of you are going to be taking the data analytics workshop later. So it's good if you know how to do this, for instance. So essentially, Python has a concept of using modules, packages, and libraries, and these are three very different and very distinct things, where you're basically allowed to run other pieces of code within your normal code, and that allows you to essentially use the power of other people's code in your code. And yeah, that's how modules, packages, and libraries work. So something you need to note is there's actually not only a few packages that will be of concern, I guess. And I guess in terms of like the stuff that we're covering today, it's mainly the math and the random module. So the math module is, just for math. If you need to run any function that has a mathematical basis, you can get it from the math module. You can get the floor function, you get the ceiling function, you can get the square root function, even though you can probably just do that mathematically. You can still get the square root function. You can get cos, sine, you can do like cos h, you can do a lot of different functions in the math module because they allow you to do that. So the syntax is basically that you need to use this thing called an import statement, which is like you can import an existing module. Like I can import math, and then I can math will be stored as a variable contain of type module. And if I were to call anything in that, then it will give me that thing, right? So import math.py will give me pi, and this is I think around the value of pi. So that's the idea. And just a note about ceiling and floor. Ceiling and floor are used to return the smallest and largest values that are larger and smaller than the yeah. Essentially, like if you were to put the value between the two closest integers, then if it's like if it has to go up, that would be the ceiling, and if it has to go down, it would be the floor. That's it. Other than this, the random module exists, which is allowing you to do like random number generation. Like you can do like a number between 0 and 1 you by a random dot random. You can generate a random value from a range. So rand range, what it does is essentially it computes the range and it gets chooses one value from the range. I guess it doesn't actually do that. It's faster than that, but that's you can think of it as doing that. Then random dot choice picks a random element from a list. That's it. So the idea is that there's another thing called a seed. So actually, when you do random values in Python, they're not actually random. They're just like they're encoded into this thing called a random digit table, where you just like keep taking values from there. And what random.seed does is it allows you to do that. Well, like you can it allows you to go to any point within that random digit table and just like take a value from there. So that allows you to maintain consistency of your random results as well, because sometimes you need to do that, especially when you're doing AI. So yeah, that's I guess another thing that you need to note about the random module. So now let's get to the next point, which is the root die. And what this does is it allows you basically spin a dice via using a random generator that gives you a value between 1 and 6, and then it finds the square root of the value. So for now, I'll give you guys about 3 4 minutes sorry 3 minutes to just like try this out. Reconvene at 12:44 if that's okay. Yep. Okay, yeah, so let's reconvene. The idea is to just take a random number between 1 and you put 7 because of the range exclusive bound thing, and then you run math square root over it. That's it. So the next thing is, and this is a bit more complicated, so I can give you guys about 6 minutes to do this. So basically what you need to do is you need to print out this statement, but you randomly generate this value, you randomly generate this value, and you randomly generate this value. So yeah, I'll leave you guys to do this as well. Yep. Okay, so the method to do this, and I think I'll just use idle from now on, is essentially what you do is you import the function modules, of course, then you define a flavors list, and then you can define a function that takes a number, which is just a random the rand range, takes a flavor, which is a random the choice, a day, which is a random the rand range with a step of 2, and prints it together at once. And that makes allows you to do this. So if I were to run this again and run this again, it will give me the values. Yeah. So I guess that summarizes most of what we wanted to cover today. And that's basically the Python stuff.